I'm working in this area of design and art with new media since 1991. And since this time, media or the technology really involved a lot. And as a designer or as an artist, my work also partly involved with this kind of changes. And that is what it makes so interesting. And as we saw, the Kinect now is a wonderful example for a product which suddenly becomes available for actually for consumer technology, which becomes available for the consumer market, but on the other hand provides such great possibilities in terms of hacking it and do different interesting things with it. And I also want to start to show one project I was using the Kinect for. Some time ago, a friend of mine asked me to participate at a workshop in China, and this workshop involved the work with Kun opera performers. And Kun opera performers are very traditional, actual intangible heritage, cultural heritage in China. So a way to perform which was kind of passed from one generation to the next generation to thousands of years in a very precise way. So the performers are kind of, can be considered as physical storage systems of a certain culture. By repeating it in a very precise way. They had to went to this kind of schools 10, sometimes 20 years before they were allowed to perform. And there are not so much schools existing anymore because, of course, nobody wants to do that nowadays. And the director who invited me to participate at that workshop wanted to create a certain bridge between the traditional performers and modern theater. And I was thinking, okay, maybe I can use new media to kind of, let's say, hack this storage systems in a way so that they are starting to improvise or do things we are used to do in modern theater. So what I basically did is I used the Kinect to track the bodies, but I didn't show the bodies themselves in a very accurate way, but I rather show elements which were invisible before. So kind of, that's my notes here, to kind of change the perception or the cognition of the dancer's body in order to make them or question their physical presence. And so they saw a real-time system which shows different things related to their motion, but they didn't saw their bodies. And so they saw, for example, a kind of a kind of virtual particle system that describes movement in space without seeing the body. So dynamics which are kind of translating the motion into the negative space. Or certain elements which are showing just the outline between different joints. And while doing that, of course, they changed their movements because they saw something which haven't been used to before, and then kind of control this new shape or this new virtual embodiment. They changed their movements. And that was a quite interesting experiment, but also experience, which I also kind of developed a little bit further in terms of translating the whole thing into the virtual space. Here we see an example in which, let's say, the Kinect tracking is not just translating a motion into something virtual, but it also kind of gave the performer the possibility to yeah, manipulate the space, like, you know, draw something into space, which later becomes some kind of even a musical instrument which makes some sound. I don't know. Normally one should hear sound now, but no. Strange. Let me see if the sound is working. Not sure if it goes to the HDMI or to the. Okay, good. Maybe this mini check interfered a little bit. Yeah, so there are different examples, and basically these are experiments, and they're going even into a direction where the dancer or the joints of the dancer becoming some kind of nodes, which became activated by becoming intersect with some kind of, you know, this wall, which is actually something like a playing head moving from left to right. And based on the form of gestures, the melody becomes different. Sorry. These are similar approaches, but without the body. So here is no body at all visible anymore, but rather an abstract shape which defines a certain structure of sequencing events that are directly translated into audio. So these are rather tests or experiments which are playing with this idea of embodying a certain structure, either human structure or virtual structure, and then transforming it into a sound or composition. This is a mathematical structure, by the way, so it becomes a tractor. And here we see some very basic AI simulation in which the program listens to what's happening outside, so it receives audio input. Then it scans that input again with a certain delay. It translates it into different tonality, receives it again, and by doing this over and over, there are some rhythm showing up by the time. So it's some a very simple program with a small memory that starts to improvise with itself. Or music based by agents. Some other experiments. Actually, this is a part of a module I used in connection with performers. So I'm using the Kinect joint rotation data in order to control the rotation of this middle beam, and while intersecting with these other squares and elements, it creates different sounds. But the question is, now we're seeing the video mainly, but we are not seeing the performer anymore. So how can that be merged together in physical space? And I was working also a lot of in this area of immersive systems, which I want to show now quickly, maybe in some projects. Yeah, this, or maybe I can show this in a as a quick time. Yeah, this is a student project in which they were creating visuals for a 360-degree environment. And these visuals are perfect in order to be merged with kind of performance, which are using the Kinect or other tracking mechanisms and translate this information into visual information. We see here some tracking or some motion, but this is not real time. But this is something I'm kind of working on at the moment. Yeah, this has 5 projectors. So there is some technique. I don't know how if you're more interested in the technical part or the aesthetical part, or but of course, there is a lot of things involved in terms of get this stuff seamless into this 360-degree environment. I can maybe show you a quick example of.
What did you use to blend
for the edge blending, or I used VVVV for anti-distortion and edge blending. But there are a lot of different software you can do it, so it's just not just related or possible with one particular software. But basically, in order to explain the principle, maybe now it plays 2 times. Maybe I can quickly show this one. Yeah, this is a schematic view of such a 360-degree environment, and what you see here is everything is surrounding the environment seamless. So there's one source, and here we actually have a view on, let's say, the core. So this might be some 3-dimensional particle simulation or simulation of objects in space. And what basically happened is that 4 or 6 cameras are looking from the middle to the outside, from this center point to the outside. And these cameras, or the footage of these cameras, get transferred into the signal which is sent to the projectors. That's the basic, let's say, principle in order to create that seamless simulation. Of course, there are some more steps like the anti-distortion and the edge blending involved to get this done finally, but the most important thing is especially if you want to use some 3-dimensional simulation, that these cameras here are virtual cameras, are looking from the inside to the outside, and then it's like an inside-out roll, California roll, which is mapped then on this projection screen. Same with the or similar possibilities are provided by dome projection. This is also something I have done very often. Here we see some student works. So this immersive environment providing the possibility to really merge, let's say, some tracking, real-time performance with a presence of media which can compete with. Compete is not really can interweave with the performance in a seamless way. Another project. It's also using 360-degree, but more in a research context, is this one. This is a collaboration between my university in Hong Kong and university in Australia, and it's a system that works with a lot of big database in in that particular case, data which is coming from museums, like archives, visual pictures, images which are indexed in a big archive. And of course, if you have such kind of surrounded information space in this scale, you can map a lot more information than you can map on a screen. And my part in this project is basically taking care of the interaction design. So that now I'm switching a little bit from this artistic projects to more applicable projects. So this is research projects, or these are research projects in which interaction design becomes very important. Questions how to navigate in such spaces, because on one hand there is really huge possibility in terms of showing things, similar things at the same time or different things at the same time, but it will be never enough to show the whole content. That means there is still selection and navigation orientation involved. So very interesting for museums, this kind of applications. Another project I want to show is also related to museums. Is a robot design. Actually a very simple robot design. So the robot has wheels, some sensors, which allows him to orient himself in space, and a touch screen. And the purpose of this robot is to guide people in either museums or shopping malls. So you have the possibility to select a certain location, and then the robot will start to go there, and you can follow him. And if nobody is there, they're doing some choreographic stuff. Yeah. It's very simple, but I mean, it sounds very simple, but I still like this idea of having just robots with a certain purpose. And in that case, also the design is very important. It's very pure. It basically doesn't do much beside connecting these two functionalities, the movement, and then it has this shape to the touch screen. Yeah? So this is a very, very pure design, basically. Another product I did is maybe a bit more complex. Is a watch which has a very individual way to show time. It actually only has 60 vertical bars, and now it's midnight. And, this is the second handle, and the second handle moves from left to right. And what you see here indicates either minutes or hours. So these dots are, let me move a little bit forward, are indicating how the minutes are coming in, and then the hours coming in, the full hour. So now it's, for example, 1 o'clock in the morning, 2 o'clock, 3 o'clock, and this is 6, 9, and 12. This goes on till midday, till noon, till the whole watch becomes white. And then in the afternoon, darkness comes in again. So now it's 6 o'clock in the evening till it gets dark again. Actually, that watch it's really existing. I have it here on my wrist. You can have a look. It's really working. Although it's Hong Kong time, but it's only inverted because it's 12 hours in advance. This idea came in my mind when I wrote a book called Grids for the Dynamic Image. normally grid systems are meant to, kind of measure or define two-dimensional space, like an editorial layout or something like that. But if a grid system has to measure, let's say, a dynamic space, then you deal with the third dimension and even with time. And let me show you some example of that book. So I wrote that together with my colleague Tanja Dietzmann. And so we did a lot of experiments in order to find certain concepts to measure dynamics in grid systems, or even to define a grid system and then to measure with that grid systems. And after we did all this, we had to kind of let's say downgrade everything because the medium for that was a book, which is two-dimensional. And this process was very interesting because we made this kind of loop from very high-dimensional complex space again into something two-dimensional, very simple. And so there was a considerable amount of experiment and research just related to merging down dimensions. And one research was related to the question how much dimensions need time to be visualized, and turned out it's.
He works with Olga and Ralph. They could have a long talk with you about time.
Okay. So I found out one dimension is enough. And I just changed the time dimension into the x dimension, and that was good enough. Last thing I want to show is maybe is there still a little bit time? Yeah, my new book. The new book I wrote is about creative education and dynamic media. It's a bit related to my work I did the last 3 or 4 years in Hong Kong, focusing on teaching and research, but mainly on teaching. And I was kind of, it was the first time I taught for such a long time in Asia, in Hong Kong, and I found that teaching has to be adapting a little bit in terms of teaching in Hong Kong. So I came up with this is mainly related because it's not so much related to the students, but to the school systems. School system in Hong Kong allows almost everybody to study art and design, no matter if this person has certain creative talents or not. So it's basically the selection process considered the overall grading. So if you're good in biology or math or physics, you can also study design and art, which means that one has a high diversity of students in the classroom, which actually became, and a lot of students who are actually haven't done any creative work before, but being interested in art and design and kind of waiting to being educated. And that's some kind of, and that raises this question about where does creativity emerge and how, or is it maybe already there and just has to be reconnected somehow? And in order to find certain methods to, let's say, because I rather believe creativity cannot be taught. It just has to be somehow re-established or reactivated. And this book gives some let's say thoughts about how that can be done by also working with these old Bauhaus principles of called the Vorkurs, or the basic foundations of the Bauhaus School of Design in the 1930s, developed by mainly Johannes Itten. So it merges everything, starts in a very basic way and then gets into a digital level. it's a huge topic, so maybe I don't talk so much about that. So thanks for your attention.
So